Find the force F in pounds force. In this problem, a reservoir of water is held back by a gate. From the cross-section below, we notice the gate is semicircular, having a radius r equal to 2.5 feet. Since the water surface reaches the top of the gate, we know the depth of the water, d, equals 2.5 feet as well. And the base of the gate, there is a hinge. The problem asks us to find the force, F, which will keep the semicircular gate positioned vertically by resisting the hydrostatic forces of the water pushing against the gate. In this problem, we'll define point A at the top of the gate, and we'll define point B at the hinge of the gate at the bottom. If we set the sum of the moments about point B equal to 0, the moment in the counterclockwise direction is the force, F, times the radius of the gate, r. And the clockwise moment is the product of the magnitude of the hydrostatic force, Fh, acting on the gate at a distance of r minus y prime from the hinge of the gate. If we solve for the force, F, we're left with an equation involving the variables Fh, r, and y prime. Since we already know the radius of the gate, r, we only need to solve for the variables Fh and y prime. The horizontal force caused by the water, Fh, equals the hydrostatic pressure at the centroid of the gate, Pc, times the area of the gate, A. This pressure, Pc, equals rho times g times dc, where dc equals the depth to the centroid of the gate, which is a different value than y prime. For a semicircle, dc equals r minus the quotient 4r divided by 3 pi. The area of a semicircle equals 1/2 times pi times r squared. After making these substitutions, we'll write out our equation for the hydrostatic force Fh. Since we know the radius, r, we can substitute in that value. For variable rho, the density of water, equals 62.3 pounds mass per cubic foot. And on planet Earth, the gravitational acceleration constant, g, equals 32.2 feet per second squared. Also, we'll multiply this value by a unit conversion. This makes the hydrostatic force equal to 880.1 pounds force. Now that we have variables Fh and r, we are left to figure out the value of variable y prime. Y prime refers to the distance from the top of the gate to the point where the resultant hydrostatic force Fh is acting upon the gate. We'll write out the equation for y prime, which involves the variables r, yc, icx, and a. For a semicircle, the term yc equals 4 times the radius divided by 3 pi. And the area of the semicircle, A, equals pi r squared divided by 2. The area moment of inertia taken about an axis parallel to the x-axis and running through the centroid of the gate is also a function of the radius r. After writing out a revised equation for variable y prime, we can plug in the variable r, and this makes y prime equal to 1.743 feet. At this point, we can solve for the force F. After substituting in the variables y prime, r, and Fh, the force F equals 266.5 pounds force. When reviewing the possible solutions, the answer is A.